Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello future engineers, here is another video in Engineers in Progress, particularly on the topic equation of the locus. So allow me to present the solutions to these three problems. There are three problems I think here with less animation so that I can discuss the solutions in just a short period of time. When you say equation or the term locus means path, and the path is traced by a point moving or constrained to move according to some certain law. Then that law should be interpreted algebraically, and from there, by simplifying the equation, the resulting equation, it represents the equation of the curve that is traced by that moving point. So that's the definition. And the technique here is once the equation of the locus is identified or written, then we find a point on the locus and substitute it to its equation, and the equation should be satisfied. I will present that, or I will reinforce that later in our examples. So let us say this is the coordinate axis, x and y axis, and we have the locus. There's a point on the locus with coordinates x comma y, and it may be there is a line, there is another circle or curve, or a point, and this point is constrained to move according to some certain law, and we interpret that algebraically. So that's the locus. So the law should be interpreted algebraically and to be transformed into a correct equation. The resulting equation is the locus. So this is the first problem. Find the equation of the locus of a point so that it passes through the points -1, 2 and 3, -3. Solve in as many ways you can. So since the moving point passes through these 2 points, so that means the locus is a straight line, and we'll find the equation of that straight line in many ways. So I present three methods here. One is, so after we plot the points -1, 2, and 3, -3, so this is the traced curve, which is the locus of this moving point with coordinates x, y, always represented with the moving point x, y, and this is the locus. It points this green locus here. So that means the slope of the line segment joining P1 and P is equal to the slope of the line segment joining P and P2. That's the first way. So beginning with x, y, the slope is delta y over delta x. So begin with the same point. So y minus 2 over x minus -1 equals the slope of P2 is y minus -3, or -3 minus y, -3 minus y. So since we begin here with y, so we also start here or begin here with x. So 3 over 3 minus x. So we cross multiply. We have to cross multiply 3 to y minus 2 first. So 3y minus 6. That's it. Then x, negative x times y, negative xy, negative x times -2, 2x is equal to, this is x plus 1. So x first, x times -3, -3x, then 1, this is x plus 1. So 1 times negative 3 is negative 3. Then negative y times x, negative xy, and negative y times 1 is negative y. So we can cancel negative xy as shown. Then in the left side of the equation 2x, in the right side negative 3x, transpose negative 3x to the left. So 2x plus 3x is 5x. Then 3y, this 3y here, plus y, negative y to the left is plus y, so plus 4y, then equals negative 3 transpose negative 6 to the right, negative 3 plus 6 is positive 3. So 5x plus 4y equals 3, or 5x plus 4y equals 3. So that's the equation of the locus. If you check, if you substitute negative 1 and 2, 5 times negative 1, negative 5, plus 4 times 2 is 8. Negative 5 plus 8 is 3, and 3 equals 3. So that checks. Solution 2, this time we have the slope of the line segment joining P1 and P2, or P1 and P should be equal to the slope of the line segment joining P1 and P2. So that is y minus 2 over x minus negative 1, or x plus 1, is equal to negative 3 minus 2 over 3 minus negative 1, or over 3 plus 1. So cross multiply, this is 4, 4 times y is 4y, 4 times negative 2 is negative 8, this is negative 5, negative 5 times x, negative 5x, negative 5 times positive 1 is negative 5. Transpose negative 5x to the left, so we have 5x, then plus 4y, negative 5 plus 8 is 3. So it's the same as that. Finally, we apply area by coordinates. We arrange the points in counterclockwise direction. So let us say this is the first point, and x comma y is, let us say, somewhere here. So in counterclockwise direction, x comma y, then negative 1 comma 2, then back to the original point 3 comma negative 3. So if these 3 points lie on a straight line, there is no area of the triangle. So area is set to 0. So 1/2 of 3 negative 3 xy, negative 1 2, back to the original point, initial point 3 comma negative 3. So 1/2, or 0 times 2 is still 0, then equals 3y, this is 3y, plus 2x, negative 1 times negative 3 is positive 3, then minus quantity negative 3x, that's negative 3x, negative y, that product is negative y, then positive 6, 2 times 3 is positive 6. So we have 3y plus 2x plus 3 plus 3x, then negative of negative y is positive y, negative of positive 6, negative 6 equals 0. Combining like terms, 2x plus 3x is 5x, 3y plus y is 4y, then positive 6 minus 3 is 3. So that's it. That's the 3 solutions I have been presenting for problem 41. So let's have problem 42. Find the equation of the locus of a point moving so that it passes through the point 3 comma 4 and is always perpendicular to the line with slope negative 2/5. Since it is always perpendicular to this line with this slope here, so the locus is another line. So we estimate the slope of negative 2/5 first. So this is the slope of a line with negative 2/5 as slope. Then we have a moving point x comma y which passes through 3 comma 4 as shown, and they are perpendicular. So we are looking for the equation of this imaginary dashed red curve. So we set a point, or locate a point on its path, on its locus with x comma y, and 3 comma 4 is also there. Therefore, the slope of this red line, which is m, the product of the slopes of this red line and this negative 2/5 is 1, because remember, the product of slopes of perpendicular lines is negative 1. So that's the equation, that's the solution to that problem. We can also generalize this as if the slope of the first is negative 2/5, the slope of this required line is the negative reciprocal of that, and that is 5/2. So if the slope is 5/2, the expected equation is 5x minus 2y equals 5 times x1 minus 2 times y1, which will be presented later. So m1 is negative 1, m times negative 2/5. This slope here is equal to negative 1, so that's why the slope of the required line, which is the locus of this point, moving point, is 5/2. So 5/2 is equal to y minus 4 over x minus 3. Cross multiply, 5 times x is 5x, 5 times negative 3, negative 15 equals 2 times y minus 8. Simplifying, 5x minus 2y equals 15 minus 8, 7. So the equation of the locus is 5x minus 2y is 7. Since the slope is 5/2, this is the other way. So possibly we're going to substitute 3, 4. But this is the expected equation. 5x minus 2y, the slope is 5/2, is equal to 5 times x1, 5 times 3, which is 15, minus 2 times 4, which is 8, and 15 minus 8 is 7. That's why 5x minus 2y equals 7. That's the equation of the locus, or that's the equation of that line there. The other way is we just substitute right away a point on its locus, which is 3, 4. 5 times 3, 15, minus 2 times 4, 8. 15 minus 8 is 7, and 7 equals 7. So definitely, that's the equation of that locus. Finally, problem 43, find the equation of the locus of a point moving so that it is always equidistant from the points negative 3, negative 1, and 5, negative 4, solved in two ways. So I'll present two solutions here. Problem 43. So let's have this moving point, and these are the given fixed points, negative 3, 1, and 5, negative 4. So the distance from the first point and the distance from this moving point to the second point is d sub 2, from the first point d sub 1, and based on this statement here, d sub 1 equals d sub 2. So we begin with d sub 1 equals d sub 2. So squaring both sides, d sub 1 square equals d sub 2 squares. By distance formula, or by Pythagoras theorem, distance 1 square is x minus negative 3. So that's x plus 3 quantity square, plus quantity y minus negative 1. So that's y plus 1 quantity square, equals distance 2 square, which is quantity x minus 5 squared, then plus quantity y minus negative 4, so that's y plus 4 quantity square. Expanding, so we have x squared plus 6x, twice the product, so twice of 3x is 6x, square of 3 plus 9 equals y square, square of the first, plus twice the product, 2y, plus square of 1 plus 1, equals x squared, negative 5x times 2, negative 10x, negative 5 squared, 25, plus y squared, 2 times 4y is 8y, then 4 squared is 16. So we can cancel x squared and y squared, x squared and y squared. Simplifying, combining x terms, so 6x plus 10x is 16x. Then 2y minus 8y is negative 6y. Then 25 plus 16, 41. 41 minus 1, 40. 40 minus 9 equals 31. Therefore, the equation of the locus, first solution is 16x minus 6y equals 31. For the second solution, this locus, as shown in the figure, is the perpendicular bisector of the line segment joining the points negative 3, negative 1, and 5, negative 4. So this point should be the midpoint between this negative 3, negative 1 here and 5, negative 4. The midpoint is at 1 half of negative 3 plus 5. So that's 1 half of 2. That's why we have 1 here. And 1 half of negative 1 plus negative 4 is negative 5 halves. So this point is at 1 comma negative 5 halves. The slope of this line is negative 1 minus negative 4, so that's positive 3, over negative 3 minus 5, that's negative 8. So positive 3 over negative 8 is negative 3/8. Therefore, the slope of this line is the negative reciprocal perpendicular to this given line segment here, negative reciprocal of negative 3/8, so positive 8/3. Then we apply the definition of slope. 8/3 is y minus negative 5 halves over x minus 1. So 8/3 slope is y minus negative 5 halves over x minus 1. Cross multiply 8x minus 8 equals 3y, then 3 times positive 5 halves, negative of negative 5 halves is positive 5 halves is 15 over 2. Then we multiply everything by 2, 16x minus 2 times 8, negative 16 equals 3y times 2, 6y, then 15 halves times 2, 15. Simplifying, 16x minus 6y equals 15 plus 16, which is 31, and that is the same as that. So that's it for this video. I hope that you were able to follow and understand the explanations and the solutions.